Hi, welcome to another ClickHouse video. In this video, we'll be designing a two-story house and seeing the seismic loads acting on this building based on the seismic requirements of ASCE 716. If you haven't already, go take a look at the earlier video I made where I do a general overview of this calculator along with some of its features and procedures. To start, we can go from the top down here. So map data and the key building properties. So these sections are the only inputs you need. Once you have everything filled out, you can see the required design parameters you might need. So to start, we can retrieve these map data values from the ASCE 7 hazard tool, which is free to use. So say setting in California, I can go find our map and let's select Fresno here. We can see obviously it's in the middle of the street, but let's just use that for example. You'll want to switch this to 716, select the risk as 2, and we'll select the soil site class here. We'll assume it's default because we don't really know what the class is. So we select seismic and then we can press view results. So once we get that in open summary, we can see we get some of these values here. I think most importantly is this SS and S1 value as well as the TL value here. So this SS value, this is the short period spectral acceleration. And then this S1 value, this is the long period spectral acceleration. And lastly, we have 12 seconds here for our long period transition period. So we can fill all of those out and we leave our site class as default. So we have that filled out, which is perfect. Next, we can move on to key building properties. We leave the risk category as 2. We're designing a residential house, residential two-story house. And on that note, let's make 2 stories, each at 10 feet. Let's keep the seismic weight the same here. Perfect. So you can see on the right, we have 2 stories now fleshed out here in this diagram. Lastly, let's leave both of these as no. We don't need to make any custom building periods or seismic force resisting system. We'll just use this light frame wood shear wall as our system. So all you can see here is in the summary, this is exactly what you'd need for designing the house. You have the SDS and SD1 values. These are important just for determining other factors later in the equation, as well as the seismic design category, which is another helpful parameter to know on which analysis you can use. In this case, we use the equivalent lateral force method to distribute vertically these loads here, which are coming from the base shear. And so this base shear itself, this is the maximum experienced load based on the estimated earthquake acceleration acting on the building here. So we can see that the 16.1 kip force here, this base shear, is distributed as 10.8 and 5.38 to these stories. And we can see each of the story weights along with the story shear acting on each level, with the bottom one being the total base shear experienced by the building. Other than that, you can see that each of the buildings have an associated height along with their number, and the total height here is 20 feet. And that is typically going to be okay for the height limits for each of these systems. In this case, it's 65 feet. So there you have it. This was a quick video on just how to use this calculator. And as you can see, it's incredibly fast just to retrieve the values, specify your building, and now you have all this information here on the right and in the summary, which you can use for designing your building. I hope that was really helpful for understanding this calculator, and thank you so much for watching. Have a great day.